Huh? How are we supposed to understand this? I know, right? It's so confusing. How about let's go watch a YouTube video?
Good day everyone. Today we're going to learn how to find derivatives of trigonometric functions using basic formulas and the chain rule. For number 1, the given problem is find the derivative of negative sine of 4x. First, the formula, the derivative of sine x is cos x. Now, apply it to the given function. Since we have sine 4x, we use the chain rule and multiply by the derivative of 4x, which is 4. Also, include the negative sign. So the final answer is negative 4 cosine of 4x. For number 2, the given problem is find the derivative of negative tangent of 5x. First, the formula, the derivative of tan is secant squared of x. Now, apply it to the function. Because of 5x inside, we use the chain rule and multiply by 5. Don't forget the negative sign. So the final answer is negative 5 secant squared of 5x.
According to its reciprocal. This could also be turned into negative 5 over cos squared 5x.
Our given for today is negative cot times 3x. First, to solve this, you must recall the derivative of cotangent, which is negative cosecant squared x. Let us now proceed to solve it. Copy the derivative of cotangent, which is negative cosecant squared, and our x, which is 3x. The method we are using is chain rule, so we must multiply the derivative of 3x, which is 3. We are not yet done since there is still the negative outside. So this will equal to 3 positive 3 cosecant squared 3x. We can still rewrite 3 cosecant squared 3x in sine form. Since cosecant squared in sine form is equal to 1 over sine squared times x. So let us apply the answer. So this will turn into 3 all over sine squared multiplied by 3x. So those are the two possible answers of this equation.
Another example is the function sine squared of 2x. We will use the chain rule, so we'll let u equal sine of 2x. The derivative of u squared is 2 times the derivative of u. The derivative of sine of 2x is cosine of 2x times 2. Now, we substitute, and that will be 2 sine of 2x times 2 cosine of 2x. Simplifying it, this becomes 4 sine of 2x cosine of 2x. Using the identity, the final answer becomes 2 sine of 4x.
So our problem here is sine squared 2x times cosine x, and we must use the formula f prime g plus f g prime. And to get our f prime, we must bring down the 2 here, which makes it 2 sine 2x. We get the derivative of sine, which is cosine, and then 2x. After that, we derive the inside of 2x, which is 2. Now if we times it all, we get 4 sine 2x cosine 2x. Now, but if we use the double angle identity, which is 2 sine theta cosine theta equals to sine 2 theta. we will get 2 sine 4x. Now, let's put this in the formula. 2 sine 4x times the g, which is cosine x, plus our f, which is just sine squared 2x, times the derivative of cosine x, which is just negative sine x. If we add or times all of this, add, we get 2 sine 4x cosine x minus sine squared 2x sine x. This is our final answer.
We are given the expression d over dx of cosine x divided by secant x. First, we simplify the expression. We use the identity that secant x is equal to 1 over cosine x. So, cosine x divided by secant x becomes cosine x times cosine x, which is cosine squared x. Next, we differentiate cosine squared x. To do this, we use the chain rule. The chain rule states that the derivative of u squared is equal to 2u times the derivative of u. Let u equal cosine x. The derivative of u cosine x is negative sine x. So, the derivative becomes 2 cosine x times negative sine x. This simplifies to negative sine x cosine x. Finally, we use the identity sine of 2x equals 2 sine x cosine x. Negative 2 sine x cosine x becomes negative of 2x. Therefore, the final answer is negative sine of 2x.
Now let's move on to our next example. We have d over dx is 1 plus cos x over tan x. Now since we are dealing with a fraction, we're going to be using the quotient rule. As we know, the quotient rule is the derivative of f of x times g of x minus f of x times the derivative of g of x over the denominator squared. Applying this to our function, we will have negative sine x times tan x minus 1 plus cos x times sec squared x over tan x squared. Now, stop right there. Before we continue, let us remember that since we are dealing with trigonometric functions, trigonometric identities are essential factor to solving these types of functions. In this function, we will be focusing on quotient identities and reciprocal identities. Firstly, let us identify what to simplify. As you can see in the first term, tan x can be simplified into sine x over cos x. And in the second term, sec squared x can be simplified into 1 over cos squared x. Now that we have simplified, we can proceed to multiplication. With that, we will have negative sine squared x over cos x minus 1 plus cos x over cos squared x over tan x squared. Notice that there are different denominators. Therefore, we have to find the common denominator. To do this, simply multiply cos x to the first term's numerator and denominator, as cos x multiplied by cos x is equal to cos squared x. Now that we have done that, we can now combine them, and we will have negative sine squared x cos x minus 1 plus cos x over cos squared x over tan x squared, which is simply tan squared x. On to our final step. Don't forget to simplify the denominator. According to the quotient identities, this would be sine squared x over cos squared x. Canceling out cos squared x, we can finally arrive to our final answer, which is negative 1 minus sine squared x cos x minus cos x over sine squared x. And that's it. You can also isolate the negative sign, which will give us negative 1 plus sine squared x cos x plus cos x over sine squared x.
Now for our next example, we have to find the derivative of cos squared 2x tan x. Step 1. We have to differentiate each part. The derivative of cos squared 2x is equals to 2 cos 2x times negative sine 2x times 2. So this becomes negative 4 cos 2x sine 2x. Now we have to differentiate tan x. Tan x is equals to secant squared x. Now we have to apply the product rule. So overall, it will become negative 4 cos 2x sine 2x times tan x plus cos squared 2x times secant squared x. Now, simplify the first term. So by simplifying the first term, we will get negative 4 cosine 2x times 2 sine x cos x times sine x over cos sine x. Now we have to cancel the cos x. So it will become negative 8 cosine 2x sine squared x. Next, simplifying the second term. So that means our final answer is negative 8 cos 2x sine squared x plus cosine squared 2x over cosine squared x. And that is how we differentiate that problem. Thank you.
Now, let's proceed to another equation. Given y is equals 1 plus cosine x over 1 minus cosine x, we will use the quotient rule and express the derivatives using prime notation. Let u equals 1 plus cosine x and v is equals 1 minus cosine x. Then u prime is negative sine x and v prime is positive sine x. Applying the quotient rule, the derivative is v times u prime minus u times v prime over v squared. Now, let's substitute it. At this point, I will not distribute. Instead, I will factor out negative sine x. So, the numerator becomes negative sine x times the quantity 1 minus cosine x plus 1 plus cosine x. Now, simplifying inside the parentheses, 1 minus cosine x plus 1 plus cosine x equals 2. So, the expression becomes negative 2 sine x over 1 minus cosine x squared. So, therefore, the derivative of the function is 2 sine x over the quantity 1 minus cosine x squared.
Our problem is 2 cosine x all over 1 minus cosine x squared. So what we're going to use is the quotient rule, which is g times f prime minus g prime times f all over g squared. Let's say our numerator is f and our denominator is g. So we're going to input the following. 1 minus cosine x squared times the derivative of 2 cosine x, which is negative 2 sine x, minus the derivative of 1 minus cosine x, which is 2 sine x, and 1 minus cosine x. And then we'll just copy the numerator, which is 2 cosine x. We're gonna put that all over 1 minus cosine x to the power of 4. The reason why it's 4 is because there's already a squared in the formula, and there's also already a squared in the given number. Times those together and then we'll get 4. Next, we're going to times everything. 1 minus cosine x squared times negative 2 sine x. On the other side, it will become negative 4 sine x cosine x, because you're multiplying 2 sine x and the 2 cosine x, times 1 minus cosine x. We're not going to put the denominator for now. Negative 2 sine x times 1 minus cosine x minus 2 cosine x times 1 minus cosine x. So we're going to rewrite that again, but this time in differently. So negative 2 sine x times 1 minus cosine x, then times 1 plus cosine x, all over 1 minus cosine x 4, times 1 minus cosine to 1 plus cosine, which will become sine 2x. And then we're going to cancel out 1 minus cosine x to the denominator. And then this will create our final answer, which is negative 2 sine x plus sine 2x, all over 1 minus cosine x to the power of 3. The reason why it's 3 is because the moment we canceled the 1 minus cosine x, the fourth 1 minus cosine x got removed, but there's still 3 remaining. So that's why we put to the power of 3. And